That's all programmed into this intelligent model. Sometimes it's referred to as a digital twin, which is a digital representation of the functional parts of the building that the owner cares about.
And that's perfect. You hit right on the aspect that I want to lead into now. So digital twins. Can you explain what digital twins are and how we operate them and some of the things we do here at Procon?
First of all, I like to define what digital twins are. A lot of people use that term, but they don't know really what are we even talking about. So it's a digital representation of the building's functional characteristics. Where are all the systems? Where are all the pumps? How do you operate them? So I like to make the analogy of Google Maps, for example. So Google Maps is a digital twin of the world insofar as we use Google Maps, right? It's a digital representation of the world. It took what was previously disparate data sets, which was traffic conditions that were live, how to contact a building, the phone number, reservations, ability to go to the website, and it pulled that all together so that those previously disparate systems now all talk to one another seamlessly. We want to do the same thing for buildings. Right now you have computerized maintenance management systems. You have project management information systems. You have integrated workplace management systems. We want to make them all talk to one another and then put a nice interface on top of it so that it's easy to use and find the information you need to manage the building.
Digital twins can be used for a lot of different things. Our team's been deploying them for years now. Talk about some of the different projects we've had with digital twins and kind of how that's evolved and what our team's doing.
So we had implemented digital twins where we were able to take that 3D model that I just mentioned, and we were able to tie that into the owner's CMMS, or computerized maintenance management system, which was called Corrigo at the time, and also into the building automation system, which controlled all the energy usage and the lights and other things in the building. And they were able to use that in a way that allowed them to operate the building better. So, for example, they needed to trace out the location of pipes that were clogging. They were able to use that right on their iPad and figure out exactly where they needed to find the pipe. This way they don't have to open up a wall and destroy a wall when they don't need to. So that was a huge innovation. We've also implemented a GIS-based tool, and essentially what that does is it maps the outside and the inside, so you know where all of the utilities are that are running to and from the buildings, all of the roadways, and then inside the building you have all of the mechanical objects, electrical, the plumbing objects, all of the operations manuals, the product data, startup, shutdown procedures, the tools, the spare parts. It's all available on an easy-to-use iPad. So the guys who are out there in the field aren't wasting all their time looking for where an asset is, or once they find an asset, how to operate the asset or fix the asset.
Yep, you're talking about quicker turnaround times, quicker efficiency, and getting into the processes of actually fixing what's broken.
Yeah.
So let's talk about how it's made. There's two different processes, right? There's the construction process for new buildings, and then there's the existing facilities. Can you elaborate on those two different areas and how we make our digital twins? Let's start with the new construction.
So new construction, first of all, there is a designer of record, an architectural engineering firm who typically will draft the drawings and the design or issue for construction package using 3D models, also known as building information models, or BIMs.
Yeah.
Typically that's a Revit, which is an Autodesk product. It's an intelligent representation of the building. That is used as the basis of design. Then during construction, we are tracking progress using visual intelligence capture. What that means is that we have on the hard hats of our inspectors 360-degree cameras, and they are capturing the walk and all of the actual conditions of the building as it's being built. We combine those two data sets to form a digital twin.
So with that system right there, we know a lot of architectural contracts, engineering contracts, they require the BIM portion of it. You're talking about we're layering a layer over top of that to actually track progress of installation for construction work that then gets uploaded into the BIM model. And then from there, there's a full 360 camera picture of every room and integrations along the timeline of when it was installed.
That's correct. Yeah, and one of the things about a drawing or a 3D model is that you don't know if it's really true. The only way to really tell if the drawing is accurate is to go out into the field, take a look and measure. What the photographic capture gives us is the ability to avoid having to do that. And we basically just leverage existing resources who are already in the building on their hard hat, putting that sensor or that camera and capturing those conditions. Now we know that what the drawing says is true or not.
So that's a good insurance package that Procon adds because when we put inspectors on site, project managers on site, and they're walking every day, we're making sure that that's getting built in, and it's an added tool for the owner down the road to be able to do all of that. And then you talk about a facility person coming in to operate it. At any point in time, they can turn around, walk up to a computer and say, what's behind this wall? And they no longer have to do demo on that wall to understand that the pipe isn't installed there, it's 2 feet to the left, or the VAV box isn't in that ceiling tile, it's over in this ceiling tile. That's a big insurance policy. I bet it avoids a lot of different things like claims, demo just to do exploratory stuff. Now, when we move over into an existing facility, we're doing this right now, what's the way that we're tracking some of those items and going and doing that digital twin for owners?
So in that case, we have an existing facility that's been around typically for a while because we are asked to do this job on buildings that don't have good records.
So you're talking about like a 1960s building that, you know, somebody handed a USB drive with this addition and somebody did a remodel here and here was a USB drive. And that owner no longer has a coherent system of tracking all the stuff that was installed, and even if they do, the drawings don't always tell you what the actual conditions are.
Exactly. Yeah, so that's a situation where what we do is we come in and we can use a variety of different technology. We can come in with our laser scanning backpacks and we will scan what's visually something we can see, and we will create a base model from there. And then based on the system that you need to track, we can then do further mapping. So for example, if the owner wants to see what's above the ceilings, we might have to pop ceiling tiles to scan that. Or if they want to see behind walls, we might have to do some destructive testing. Other information can come from computerized maintenance management systems to say what assets are make, model, serial number. We basically combine all of that with all of those historical drawings to come up with a master drawing or a master model of what is there, which can be called a digital twin.
And you just hit on something perfectly. So there's a benefit to the owner in this. Like, they're not just spending money just to have this awesome layout and know what's where. There's benefits to it with their asset management, right? So let's talk about those a little bit. Can you hit on some of the benefits that the owner sees after this digital twin is turned over?
So especially in the case of where we do construction monitoring with the reality capture 360 photos, when we capture what's behind the walls before it's closed in, you basically have X-ray vision. So I don't know if you've had this case personally, if you have a leak in your house, you know, where the heck is this leak coming from? Mm-hmm. That's a problem that happens all the time in commercial buildings, and having that information is amazing. But you know, what you need to operate the facility is typically to know where the asset is, first of all, where the systems are, where are the pipes that connect the assets, where are the valves, and then what are the procedures to operate that asset, whether it's preventively or whether it's to correct something that's gone wrong. And that involves what parts are needed, what are the tools that are needed to service this, and how often should we be servicing this, what's the shutdown, startup procedures. All that information, if it's not readily available, leads to what we see commonly in the industry, which is that it takes a while, A, to find where the asset is or where the problem is, and B, then to know what tools should be used, what processes, and what parts need to be used to service it. So with large building owners with millions of assets, if it takes 2 or 3 or 4 times to service those, you can imagine there's huge efficiency losses.
And I say this knowing that the industry and the trade workers, there's less of them out there, and we have a shortage of labor. You know, when that person is, you know, no longer there that has the 20 plus years of facility knowledge, and you need to know where something is and what to replace and how to fix it, other than just calling for a brand new make and model to be delivered to the site, that's where this comes in as a great benefit, because now you can have somebody with 3-5 years experience come in and look at something on the drawings that we've laid out in a digital twin, and it says, here's the make, here's the model, here's how to fix it, here's the part number, here's what needs to be done, and it has all of those submittal instructions from back in time that have been built into this digital twin. So those tools all combined together. What are some of the things that the team is being cautious of with data governance when we're talking about tying tools together and how those software speak and how things go back and forth.
We'd love to have a perfect digital twin of the built environment implemented. And that's all well and good for the moment that the digital twin is implemented. But what needs to happen is that the digital twin needs to stay up to date to constantly reflect the existing conditions of the built environment. Sort of like the Google Maps analogy I made before. Google Maps is valuable not just because it was accurate at some point in time, but because it's accurate at all times. And the only way to achieve that is through data governance. That is a governing framework that allows us to specify what information needs to be gathered at what point during the life cycle of the facility from which stakeholders, and then where that information goes, what systems it lives in. When a system update is made, there's a certain procedure that allows for all the other systems to reflect that change. For example, is there a naming convention that's been updated? If that's been updated in one system, has to update across all of the systems. And that affects the overarching digital twin ecosphere, if you will.
Yeah, and so we have a lot of evolution since we had Access databases and Excel spreadsheets to manage a lot of our data. So our implementation and development team, they're looking at these systems and they're saying, how do we make them talk? How do we, like you just said, how do we make A equal B? And how do we make that information shared across platforms so that when you finish a construction project, you're able to transition the data over to the facility team? So lots of cool things going on here at Procon, lots of things we can dive into. I think, we have more subjects we need to cover at some point here soon.
Absolutely.
More to come.